Okay, chapter 2, unit 2, whatever you want to talk about. Typically, after we do all this intro stuff, we get into, that doesn't normally take very long. We do something called kinematics. Now, if you ever go into a Word document and you type in kinematics, they're going to tell you it's not a word. Obviously, a physics person didn't program a word, because I do think it puts the little red line underneath it, but my computer did not, so I'm not sure. Kinematics, all right? Kinematics versus dynamics. Spelled kin-e-mat, best word ever, ix. Mine's spelled with 2 T's. Kinematics versus dynamics. Kinematics is motion in one, well, no, it could be motion in a couple of directions, but it's motion without regards to its causes. Motion without regards to its causes. You're playing soccer, you kick the soccer ball goes flying through the air. The fact that you kicked it is a force, but kinematics does not care about that. It does not care about forces at all. It only cares that the object is moving. So it's without, I'm going to spell regards wrong, tell me. R-E-G-A-R-D-S. I swear that's what they told me. I wanted to put like guard like a soldier. Without regards to its apostrophe S? I'm just not going to put it. Without regards to its causes, okay? So you folks probably do not know who Gary Coleman is. I think he passed away. But he was on a show, Different Strokes. I love Different Strokes. To this day, they had a Halloween episode, and I had to go walk in a parade for Cub Scouts or something, and that was it. Cub Scouts was it. And I missed the ending of it. I never got to see it. So when I think of kinematics, I think of Gary Coleman. I don't know why. Because in this one picture I used to have in the PowerPoint, he's like this, and I had above the head, who cares? Like, who really cares? And it's talking about kinematics. It does not care why the object's moving. Obviously, dynamics tells us why or how the object moves. Okay? So when we talk about the two, over here we're talking about velocity, and you'll see this in the PowerPoint. We're talking about velocity, displacement, and we'll talk about what each of these mean, and then acceleration. On the other side, with dynamics, we would be adding mass and force. Okay? Mass and force. So, forces move objects. We're doing kinematics. We don't care about them. Okay? So let's take each one of these individually and talk about what each one is. I kind of started mentioning this in another video. Maybe I shouldn't have. But I think now will be perfectly fine to talk about velocity versus speed, displacement versus distance, and then acceleration. All right? This is Chapter 2, Unit 2. Chapter 3, we're going to talk about two-dimensional motion. In this chapter, we're going to talk about either x direction or y direction, independent, not having them both at the same time. And then in the next chapter, we'll talk about projectile motion, which we're not going to be able to do something that the guy here, sitting here, actually did. Maybe we'll try it later. Shooting hoops. Shooting balls through hoops, putting targets on my bald head, and hitting it. All right, so let's do displacement first. It is an x with a half arrow over it. It is a vector. It's in a certain direction. So if I were to tell you, and I always do this in class, if I were to tell you, okay, I live, I forget what it is, 38 miles now, 42 miles, something from here. I live in Meadville, if you didn't know that. And that would be no help. That would be the distance, okay? I live 42 miles. Oh, that's great. Now, if I told you I lived 45 miles, 42 miles northeast, actually, what? Southeast, or gave you a certain an angle or something like that, that would be displacement, okay? I always joke and say if I only gave you 42 miles, the easiest way to find my house would be to get a big rod, ding, 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 nail it into the ground, get a rope that's 42 miles long, and basically make a big circle and just keep knocking on every door you come to. Students always give me a hard time with that. They say, well, you would run into trees, and the houses wouldn't be able to have the line go over the houses. You're thinking too much, okay? So that's displacement. Now, velocity tells us how fast something is going and in what direction, okay? So velocity is a v, which I cannot spell today or ever. So a lot of times people will call it speed. Speed is simply the miles per hour, and velocity would be miles per hour, east, west, whatever. Okay, plus minus. So, our units, since we're dealing with SI, our units here is the meter, which is m. Our variable is x. For velocity, it is meters per second. It is meters per second. We deal with our SI units. And then our last one is acceleration. Now, acceleration is the rate at which the velocity is changing. The rate at which the velocity is changing. It's a lowercase a, so we have a lowercase x, capital V, and then a lowercase a. And that's actually measured in meters per second squared. Okay? So let's say the velocity is changing 2 meters per second every second. That would be like an acceleration, 2 meters per second squared. Every second you're increasing by 2 meters per second. We'll talk about that more when you're dropping a ball. But now, last one here is time. Time is always a good one to have written down. It's a lowercase t, and its SI unit is the second. Right? We're not familiar with meters per second so much right now, but we'll get better with it. Right? So those are our main variables and the units associated with them for our kinematics one-dimensional motion that we're going to be doing. All right, so here we go. Here we go. The kinematic equations. In my room, there is a what do you call it? Poster board, okay, that has some magnets on it that could go on the board and stay up there all the time of the kinematic equations. So this is our first dive into what some people would think of when they think of physics, okay? Oh, it's all those equations and you got to memorize them and all this other stuff. They're not that difficult, okay? When you go in the textbook and you look up kinematic equations, you are going to find that there's more than what I show. Okay. Not saying that's not true, but I'm going to tell you right now, the ones I give you are the only ones that we need. Okay? Those other ones are kind of specific situations, and we need to be concerned with other factors, and students will use them wrong. And really, we could use the three that we're going to use to solve any problem that we are going to run into at all. Okay? So I call them the big three, and they are this. It's funny because I didn't do them all summer, and then I'm doing the answer keys for this notebook for whoever's going to be in, and after the very first one, it was just like normal. Like I guess when you write them 10,000 times. I'm looking at you. Okay. Anyway, I guess how am I doing battery-wise?
You're good.
All right. So first one. I'm stalling because I'm trying to think real quick. I'm stalling because I'm trying to think. All right, so we have VF equals VI plus AT. Okay? So you're going to notice in the classroom or in textbooks or whatever that they're going to use a lowercase f, okay, like this. And that's how I normally write it. I don't know why I wrote it with capitals here. And then they write this little 0 here, this little O. Okay? And that's like not. Basically, that just means initial. So in high school, I always just write it as an I. Okay? I won't write that as a little O. I'll write that as an I. Why? Because I just think it's easier. Okay? When a student sees that, oh, I stands for initial, F stands for final. The final velocity, the initial velocity, the acceleration, and then the time. All right? If you choose to write capitals, that's fine like I did originally. If you put lowercase, that's also fine. Okay? You could do that however you want. I do want you to understand, though, when you look in the textbook that that little O means initial. All right? So that's number 1. Is it required that you put the vector signs over the vectors? Yes. 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 I want the vector signs on them. All right? Number 2, second one, the one that people hate. Why? Because it has a square in it. Oh no, they're squared. Okay? Just be careful. Make sure you put the square in. Don't forget it. It's one common mistake that people have. People do try to avoid it as much as they can, but they don't need to. Lastly, x equals vi, nope, that projectile in my head, vit plus 1/2 at squared. Okay? So displacement is initial velocity times time, 1/2 the acceleration times time squared. When people mess up, when students mess up this equation, they forget to put the square on the t. That's typically what happens. Okay? So in class, it'll be like, what equation are we going to use? And people normally say 1, 2, or 3. They don't really like say the whole thing. Now, I will say this. When you look in textbooks, it may write them a little bit differently. Like, for example, they will put this as the change in time. I don't do that. All right? So if I'm using a stopwatch, what time am I going to start on? 0? I'm not going to start on like 2 seconds, okay? But what they're saying there is the change in time. So like if I was on 2 seconds and it went to 5 seconds, our time would be 3 seconds. And I think that's obvious. So I don't put this change in, okay? And they also would do it here on the x, okay? They either put the change in here or they do this plus velocity plus the initial displacement on the end. I don't do any either. I don't find it to be necessary for how we do things in class. But just realize if you see that, it's not like we're doing it wrong. They're just adding a little something onto it, okay? But we would still be solving the same thing. Okay, so when trying to figure out what equation to use, you're going to be given word problems. We didn't stop after kinematics and dynamics, did we? Just kept going. That's my fault. We should have stopped. All right. So whenever we have these problems, they're going to be word problems. We're going to have to go through and figure out what each of these are. Okay? So if we know the units, meters per second for velocity, meters per second squared for the acceleration, time is seconds, okay? X is in meters. If we know that, we always should be able to get the numbers in the correct places, okay? Now, when you're also trying to figure out the equation, you're going to notice something, all right? In each of these equations, something is missing. So in the first one, you'll notice that there is no displacement. So if we're not looking for the displacement and we don't have the displacement in the problem, you cannot use the first one. In the second one, there's no time. Okay? What is the time of the event? Whatever. If it says that, you cannot use the second one. Can't do it. And then the last one, there's no VF. So VF is the final velocity. I get in my car, I start at 0, and I want to know how fast am I going at the end. Well, that's the final velocity, okay? If you're searching for the final velocity, you cannot use the last one. So for years, I didn't say this, but like, one year, this actually helped people to see this, some students to see this. No X, no T, no VF. And that helped them pick out which equation to use. Right? Now, once you pick the correct equation, what tends to happen is students will perform bad algebra. That's a struggle, okay? So the one thing you have to remember whenever you do algebra and you're in math is you cannot add unlike things. You can only add things that are alike. You can only subtract things that are alike, which means have the same units, okay? So we'll focus on that here in another video. I think that's it for now.